Vectors 1. A quantity can either be a vector or a scalar quantity. When we talk about a vector quantity, it is a quantity that has both magnitude and direction. On the other hand, a scalar quantity has only magnitude. We have examples of scalar quantities. For example, when we talk about distance or speed, those are scalar quantities. On the other hand, when we talk about displacement and velocity, then we are talking about a vector quantity. In this case, we are interested in both the magnitude and the direction of movement. That is for the case of displacement. While for the case of distance, we are only interested in the magnitude. Vector representation. Vectors are represented by straight lines with arrows to show the direction. So usually we have a straight line and an arrow to show direction. The longer the line, the greater the magnitude, and vice versa. Now, if a given line represents a vector of magnitude small a, the vector notation is written a with a vector symbol. So the vector symbol is written below a, or the vector symbol is written as an arrow above a, or a is made thick to show that it is a vector, and that is called vector notation. So we draw a line and show that it is a vector by writing a and its notation and the vector notation to show that the line represents vector a. Now, if a given length represents vector a, you are given the length, the first length here to represent vector a, then twice the length, meaning we have a and another a, represents a total vector that has a magnitude 2a. Similarly, half the length represents a half of vector a. Because direction is important when we are talking about vectors, we show the direction using positive and negative signs. So a negative vector means that the direction has been reversed. So in our case, if line A has vector A, its opposite direction, same magnitude, represents negative vector A. Equivalent vectors. Two vectors are equivalent if they have the same magnitude and they are in the same direction. Given two lines, same magnitude, same direction, then vector A is equivalent to vector B. And we write, so vector A is equivalent to vector B, written vector A is equal to vector B. Let us look at addition of vectors. Two like vectors can be added. The operation of addition changes to subtraction if the vector being added is negative. And negative here means that the direction has been reversed. For example, in the following examples, we have 3a plus 2a, and these are like vectors, and that will give us 5a. 3a plus negative 2a, so meaning negative 2a is the reverse of 2a. The equation becomes 3a minus 2a, and this gives us vector A. If the vectors are unlike, for example, 5a plus 3b, this remains 5a plus 3b. If both vectors are negative, for example, negative 4b plus negative 3b, this we get negative 4b minus 3b. That gives us negative 7a.